Chris, would you be willing?
Yeah.
Thank you very
Thank you.
much.
Thank you.
All righty.
See, this is what you get for volunteering once.
It's the downside of being good at it. So, all right. Well, then let's get started. Thank you everyone for coming. This is the Media Operations Working Group. If this is not what you expected, then now is the time to find the door and find where you want it to be. Otherwise, thank you for coming. As always, do note well, there are processes and policies involved at the IETF, and we are expected to follow them to create the healthy, functioning community that we are. Yeah, this is sort of the backing of why we do this and why we have note well policies. If you believe that you have been a victim of harassment or otherwise behavior that is inappropriate, you are urged to talk to the ombuds people and raise that issue as we all strive to create a constructive environment. I think you've probably had all of the tips here already several times, but I'll use this occasion to remind you, please do log in to the session, even if you're sitting here in the room. We will be using the queue. There's a sign at the back of the room, or I believe on the mic stand, you can. We will be using the Meet Echo queue for all of the queuing for questions and comments. The IETF 121 Dublin meeting is very resourceful. If you haven't already downloaded the agenda, do have a look. And here's our agenda. As described, we will be using the Meet Echo queue for all questions, but are there any bashes to this agenda? It's been posted for some days, some weeks now. Going once, going twice. All right, let's do it. And thank you again to Chris Lemons for being our minute taker for this session. For the working group documents update, we have two internet drafts that are in the RFC editor queue. There are no updates beyond that. At some point, they will magically pop out of the queue and we'll have RFC numbers. And as of last week, we do have a new working group document, the network overlay impacts, and Sanjay's going to talk to us about it. So Sanjay, would you like to come up and talk about it?
But I think this is set up for Glenn. He should have been here.
I understand your challenge.
That's good. There are only very few who appreciate that. Always good.
Yep.
All right. Stand up here. My name is Sanjay Mishra, and I'm just going to be giving a quick overview of network overlay. The draft, we submitted an updated version in early August, and we already got some good comments, lots of spelling errors. Apparently, we didn't do spell check. so some of that and some of good feedback. So we'll have to work on the next draft anyway. So that's upcoming. That's going to be coming up. Next slide, please. So this is just a timeline here. The latest version 2, was submitted, and we've got a couple of other feedback on the GitHub. So just have to review those, and as that makes sense, we'll review those and then pick them up if necessary. Next slide, please. So just a quick overview of what really network overlay is from the point of view that the authors have meant. So from the standpoint of the draft, what we're talking about is network overlay features that may be making some policy decisions on top of the existing network, existing ISP network, mobile networks, policy changes that could be IP assignments, DNS resolvers, routing, HTTP, etc. All of these changes are often done with a singular piece in mind to enhance privacy, which is the good thing, which is the intended uh, purpose of enhancing the end user privacy. So that's all good stuff, but there's no such thing as good deed goes unpunished, right? So there's good stuff, and then the good stuff brings some challenges with it as well. And some other challenges that we have listed out here in the document, it's just just a bit summary here, but some of the challenges from the streaming video transmission endpoint. So some of those are challenges that would affect some of these privacy would be optimal CDN selection, um, and that could be various reasons, IP assignment or DNS selection, which might take the eDNS0 field out if you were relying on your local DNS resolver to provide you the IP subnet, then you no longer have it, so you may not be selecting the optimal resolver or the optimal delivery point for that video session. There are other issues as well, performance and latency in terms of just the network path, because you may be traversing longer. And then there's the video latency, which is really not good if you're watching a video and you're paying for that subscription and there's slow or there's buffering, then that introduces additional challenges. And all of this seems to be an ISP problem then, but it's very hard to really figure out where the problem might be. Is it the network that's causing the problem? Is it the congestion that's the problem? Or is it because content is sitting at a source that's not easily traversable on the path that it is traversing? So those are the challenges that the good stuff brings with it. Next slide. So again, draft 02 was just really structured to just really focus on, are we really communicating what are the problem statements? And we still have some work to do there in terms of clarifying and appropriate text in terms of making sure that we are the problem statement is quite clear and is vocalizing what are the challenges. I think that's really is the first thing that we need to be able to do clearly. As we have a good problem statement, then solutions and things become easier to find and address. So, and then that would be the next thing, is for us to, once we have good problem statements out there, then making sure that we're working with the appropriate people and hopefully getting the feedback that will address those problems. Next slide, please. So I think this might be the last slide, but wanted to, both Glenn and I wanted to specify, wanted to really clarify a couple of things, that we're looking for contributions, specifically if you're a video player, a video service provider, video platform of any sort, you might have some input to it in terms of the problem statement, or you might even have a solution there. Or you might have both. So we're looking for folks to take a good look at it and provide any feedback or contribute. And if you are a network overlay protocol engineer working on things such as mask or OHTTP, et cetera, then you actually might be able to review the problem statement and make sure that it is really conveying the correct issues, and then maybe you can help address some of those as well. And then everyone else, please review and provide comments and questions, and you can get on the GitHub and give us the PRs.
Glenn?
You have a next slide, or we want
No, that's it.
That's it.
Glendine, Comcast, NBC Universal, one of the co-authors on this draft. First of all, let me apologize for the slide formatting. They were formatted nicely on my laptop when they were put together. They did not make it onto the screen nicely formatted. I don't know what's going on. One particular feedback we've received, and I want to address it, which was some people said, well, some of the stuff you have today is not fully fleshed out or in detail, and we would like to see specific examples citing like specific video services that are having problems with this. That's always a challenge when you're doing an operations document. Individual services are pretty loath to say, hi, I'm company X and I have product Y and it has this following problem. So we're gonna have to figure out the right path here, and we could, Sanjay and I could use some help on how to get the right level of detail without also saying, company X's product has this following particular problem, because even if that is true and then company X does have that problem, one of the things discovering and talking about this amongst many platforms is that it's a common problem that it pops up in various forms across a variety of platforms. Things like, if I change the encryption from HTTP to HTTPS, that has impacts to a lot of platforms. If I'm changing the routing path to the content, that changes for all platforms. So we're probably not going to name and shame any individual companies. We are going to have to keep it broad, but we also want detail. And so helping us understand the right place there would be very, very helpful. And of course, making contributions to the GitHub would be very, very helpful too.
Yes. Thank you, Glenn.
Yep, please.
Luis Contreras from Telefónica. Some of the problems that you have mentioned before, like network latency or CDN selection, the cache selection, and so probably cannot be afforded without sharing the information from the network itself. So would be solutions going in the direction of exposing topology and capabilities of the network would be something that could fit on this draft, or not at all, not at all, because I see basically you are calling for people working in overlays and so, but probably we need some underlay information to be exposed and maybe defining proper interfaces to do so, and so. So is that part of this, or would be different topic?
No, it will be part of this. If we can put the problem statement, then certainly we also want to put out some suggestions as to what might be the possible solutions. So, and if that involves that maybe some APIs that expose some of the information that you're talking about, that, oh, use my local DNS resolver because it'll provide you the function that you're needing, as well as it'll provide additional features that might be useful for the end user. So yes.
Okay, thank you.
Yeah, I think one of the challenges is, as a working group, we are not chartered to do protocol work ourselves, and nor do we want to sort of overly identify what other working groups should do in their protocols. But I think that's why the focus is on a problem statement in this document. But as far as documenting operational realities and operational approaches to addressing things, I think that could be helpful in illuminating where other groups might have work that they can do to address the problem in general. But it's kind of a fine line. Anything else? There was a pretty robust discussion around this in Vancouver. Are people so excited by the new draft they think it's almost done, or want time to review the draft and come back in March to discuss it further? Or you're all here for the cats, right? All right. Thank you, Sanjay.
Thank you.
And Will, I believe you are up. Yeah. Woohoo.
Sorry, I've got to choose the window that I'm going to share. Accept.
Coming. Okay. So good afternoon. My name is Will Law from Akamai.
Tilt the mic up a bit. Yeah.
I have the reverse,
Reverse the operation.
which there's so many friction devices. There. Is that better? Nope. Still loose. Tighter. So good afternoon. Thank you. My name is Will Law, and I'm going to present to you The Secret Lives of Cats, which is an attempt to make common access tokens slightly more interesting. This talk was prepared for probably a less technical audience than you are. But the saving grace is that I am just one of the participants, but the editor of this, Chris Lemons, is right here in the front, and also Gwendol was involved. So I will present slides, and then when you ask questions, you should stare expectantly at Chris. And also, this talk was prepared a couple of months ago. We can probably give you some updates along the way with its current status. But let's begin. and there's quite a delay here. So what is an access token? I think people in this room know that when I want to give data to an end user, I need to both authenticate and authorize them. And this is an expensive process. So when I'm delivering media, I don't want to repeat that operation every single time I'm requesting a media segment. So if Jane wants to watch the video, she can give username and password to the auth system. The auth system will validate her, and it will return, it'll characterize that acceptance with a token. And that token may contain constraints with what Jane is allowed to request. But then Jane takes that token and makes a segment request to the CDN. And at the CDN side, we decrypt the token, we check the claims, and then if everything's good, we give back a media segment. And this is a highly simplified version of tokenization. But it is, in fact, the essence of much of what happens for media today. And it often doesn't get very more complicated than this. So why would we even need a common access token? So there is complexity in distributing across multiple CDNs. So I work at Akamai, and we have a certain tokenization scheme. Other CDNs have a slightly different one. So if you look at some of the CMS systems for content distributors who are vending content across multiple CDNs, they have a lot of complexity on the background. And there's a lot of times you DOS your end user by just giving them the wrong token. So the idea is, and another consequence of sharing tokens between CDNs is, in order to satisfy all their different schemes, you end up negotiating down to the simplest one, the lowest common denominator. And for tokens, that's basically time. So you end up with very simple tokens that just give you the right to request all sorts of things for a limited period of time. And we see data from Bitmoving here. This is their survey they did. Most people today are using multiple CDNs. I think the figure when you get into high-level media distribution is a lot higher than 35%. I think it's in the upwards of 70, 80% nowadays. We value and treasure companies who only use one CDN, but they're very far few between. So it is a definite issue. And there's another reason for common tokens, which has just come up with all the content steering specs that have been released in the last 2 years. So HLS came out with one. In -IF, we came out with another one as well. And these happily assume you can just move your client between these CDNs. None of the examples contain tokens. And on the HLS side, you can add new query orgs when you synthesize a new pathway. But on the Dash side, we have no mechanism to do that. So unless you have a common token and you can give the same query orgs to both CDNs, you're very quickly going to run into trouble for practical levels of content steering. This is a screenshot of Brightcove's excellent content steering demo. It's public. If you haven't gone to look at it, ask me for the URL. It's quite an insightful a view into how content steering works, and it's all live. So we decided there was a problem at the CTA Wave project back in 21, which seems long ago now, but yes. We decided to create a spec for a harmonized token. The name we chose was Common Access Token. So the common part here means it's common across all players and all CDNs. Okay, and it's not actually for media players only. It's protecting any binary asset that you choose to request from a CDN. I'm trying to propose it to MOC for use with MOC as well, and we have some interest there. And the name matches other specs that I was also the originator of, which is common media client data and common media server data. So we're rolling with this common theme.
Sorry, I was trying to help. Okay,
What was wrong?
well, that's what's wrong. Sorry. It had the, yeah.
Ah.
All right, thank you.
Okay, we're back. So we have had a bunch of meetings, and finally the specs room released in the last month, or re-released. It's had an interesting release process as CTA 5007. So there's no charge for usage. You can download it and begin implementing common access tokens. So what is a CAT, right? It's a general purpose bearer token for content access. It's simple and it's extensible. It communicates different policy claims. These are things you want to enforce along with this token. And its primary use case is to be able to enforce policies very efficiently, very flexibly, and interoperably across all these CDNs. So a couple of explanations of CWT, JWT. Firstly, those are not the correct pronunciations of these words. If you go read the spec, you're meant to pronounce this jot, I believe is the correct pronunciation. And this is kot, is that right? Which sounds very Nordic to me, jot and kot, but no one that I know ever uses those terms. We all do JWT and CWT, but the majority of JSON Web Tokens today are in use, but Common Access Token uses CWT, CBOR Web Tokens, okay? Secured with CBOR object signing and encryption, which is cozy. Now, why? Why did we go down the binary route? Well, here's a typical JSON Web Token with several simple claims expressed. Here's the equivalent behavior set with CWT. If I base 64 it on the left, which is what's commonly done for transmission, I get 208 bytes. And if I do the same for the one on the right, exact same claim set, 35 bytes, so 83% smaller. So that's why we went to binary, for efficiency. It's not as human readable, but it's most of the time it's machines reading these, not humans. And it's easy enough to make a parser to show them in operation. So how do we move them? Like, how do we give them from a player to CDN? So typically we can embed them in the path. You see an example here. I've just baked the token into the URL. We can do it as a form. We can do it as a cookie. We can do it as the authorization field because it is a bearer token. And we can do it as a custom header common access token. And we've sort of reserved the name common access token with capitals there in that form, even though it's not case sensitive. And I put the tokens in the path here so they would all fit on the slide, but at the bottom is the actual length of a useful token. It's not crazy long. It's longer than these, but it's certainly not the most abuse of query args or path parameters that I've seen. So these are typically how we transmit them. And what claims can we support? So I mentioned that because of this race to the bottom for interop with tokens, you typically just give a token for expiration. But with CAT, we now expand this into a whole other set of claims. And this is where I think it gets really interesting from a content protection and authorization point of view. And not only can we apply all of these different claims, we ideally can combine them in Boolean operations, as well as logic combinations between those. So I should point out, and I think Chris will fault me if I don't, that the spec as we've released it does not contain the Booleans today or the logic. We need to get additional approval, and I believe that is on the agenda for the session tomorrow, or maybe not. Okay. Chris to the mic for explanation.
The Boolean operations are defined in the composite claims draft that is before the COSI working group. That has actually already been presented in person, and it hasn't changed significantly since then. So we're not going to spend additional face-to-face time on it. It is on the mailing list, and you are encouraged to support and or criticize that work as is your whim. The IETF COSI group. It's the and or and nor claims are in the composite claims draft before the IETF in this group, because this is the body that makes a lot of sense to work on that.
So, if those do get passed, the idea is that we could then take combinations of these claims, or them and them, and get quite complex structures. So if you're in Dublin and it's past 8 p.m. and you have paid for the UHD access and you're on an Android device, then you get granted access. So combinations such as those. Sorry, there's quite a delay between pressing next slide. So crypto, certain algorithm, the recipients certainly are required to support 3 algorithms, which is HMAC 256, 256. It is symmetric. It's very fast to sign and verify. And you got to use the same key on both sides. You got to be very careful who you share your key with, because as soon as you give it to them to decrypt it, they can also use it to synthesize a token. We've got PS256, which is also is asymmetric, slow to sign, fast to verify, has a larger signature. And ES256, asymmetric, very fast to sign. And sorry, I got a glint on my site. I can see it here. Smaller signature size, which reduces the overall size of the token. So you've got a choice. You can use something else as long as you negotiate that independently with the CDN that is going to be enforcing these tokens. But these are there so we get some level of interop out of the gate. So some high-level applications. You can do baseline CD access, and this is sort of geographic, time-based, URL-based. We can put in a token identifier for analytics. This is good for anomaly detection in the logs. How many times is this token being used? Anti-replay, if you can track all the tokens, which is difficult to do it on a global scale, but you can do it eventually and then start blocking sessions. We have mechanisms for token renewal. If you have a long-running stream, 24 hours a day, when can you rotate the tokens out? Or even a sports event, typically rotate tokens a lot faster. And then an interesting field of probabilistic rejection, which I have a separate slide on, and also DPOP as well, demonstrated proof of possession for more robust protection. So here's an example of a typical encoding. Again, this is just the diagnostic version of the token. It is binary. Our actual claim fields are represented by keys. That gets converted to something looking like this. And then that itself comes out as either binary or, in this case, base 64. So I can show it to you on the screen. As part of the development, we wanted a more sophisticated way of specifying location. Today, it's typically used with country codes. But if you say you want to block Paris, it's a lot harder to do that today. So there is a standard for efficiently resolving the surface of the Earth into rectangles and communicating these with strings. And the smaller your string, the larger the area. So you can see here we've got geohash U3. It's a portion of Northern Europe. And then the longer my geohash string goes, so I increase the resolution or decrease the size of the rectangle. It can go all the way to 9, I think it is. So you can get pretty precise. I mapped a geohash for us here in the convention center. And you can see that's only a 7 character. So we could go right down to a 3 meter by 3 meter square, I think it is, on the Earth's surface. The advantage of these is they're strings. And you can also, you don't have to give one rectangle. You can give you several blocks, right? So you can describe non-spherical or interesting shapes of the Earth that you actually want to allow access within and disallow access without. Or enforce access without and disallowed within, depending if you're using it to block or grant access. One trouble with geohash, it was just a wiki page entry, and it wasn't sufficiently rigorous for us to reference it in our specification. So the same group that's developed CAT has also developed a standardized version of geohash and published the algorithm, and that is CTA what? Do you know the number? It's another number from CTA, but as a byproduct of this, we did standardize geohash, so now we can start deploying it. 5009-A. Thank you. Everyone needed that. We were all wondering. And as I mentioned, we solved the standardization process, and you can go play with a little link that I put there and see what the geohash, you can pick a word, right? It doesn't include every letter in the dictionary, but there are certain other combinations. We wasted a lot of time, or at least I did, trying to find words that actually matched something to do with the location. So is catnip a thing? Sure is for cats, and it is the cat network IP claim. So there's no surprise there. This is just engineers being silly. But we're pretty, you can block based on the AS number. You can block based on IP4 or IPv6 addresses as well. The example there down at the bottom, if the client restricting the client to a subnet for access. So that, we don't encourage IPs are not the most robust way to protect content, but they're still in combination with other claims, they are useful. What about altitude? Now you may say, why would I ever want to discriminate against people who live at the top of mountains? But we do have a GeoAlt claim, and the use case is basically if you're trying to say allow or disallow playback in Denver. You know the altitude in Denver. You know it's not sea level. So you could actually build into your claim set that if people were at sea level, they wouldn't be allowed to access content that was explicitly allowed in Denver. I've seen it also used for aircraft as well, that can only be played back in a plane. The pressure in a plane is always less than it is at sea level. So it's another item in the checklist. And one of the more exotic ones, I would argue. We also allow renewals. So you can renew the token, the CDN. So one CDN can renew a token that another CDN has issued, assuming both CDNs have been granted the rights to renew it by the content distributor, who is the common glue between the two. And we have a number of different mechanisms for renewing. We can renew via cookies, we can renew via header renewal, and we can renew via redirection. And these are all quite useful ways of, especially for long running streams or where I want to rotate the keys frequently. And probabilistic rejection. So this is the notion that when you connect and give me an otherwise good token, I'm going to roll the dice, and some fraction of the time, I'm going to reject you anyway. And why would we ever want to do that? Well, the reason we do that is to cause pain to the pirates. And what pirates are doing is taking one token and then building a system that in real time shares it very rapidly. So, and I think Cinemedia are the authors of this solution. But basically, if you consider a token that is randomly rejected 0.005% of the time, and I'm sending it with every media segment, which is I'm using it every 4 seconds, then a legitimate user would only have a 2% chance of having to renew after 5 minutes. But pirates who are sharing it with 10,000 users are going to be forced to renew within seconds. So they're going to be forced into this renewal cycle every 2 seconds. And it's the renewal cycle where you can catch the pirates. You can see, wow, I have a lot of people using the same token. I'm going to block the renewal of this. So it's an interesting way with just a little bit of maths, and it's completely stateless at the server side. You don't need to know anything about all the other sessions. You just roll a dice and you let statistics hurt the bad guys more than the good guys. So for more on that, speak to Gwendol in the front. Very simple expiring example. So we've got a token here, and it's expiring at a certain time. Click. We got expiry. We got our cat-u claim. We got and then basically we're baking the path as one of our claims in the URL. So it's basically URL and time-based enforcement. That's what my token would look like. That's what the token looks like actually attached to a HLS playlist request. Come on, click. Okay, sorry. And I was showing the difference in key length. I went a little fast there between your verbose and your non-verbose crypto algorithm. So choose your algorithm carefully. QR code to the spec. It is now published CTA 5007. I encourage people to look at it. And at Akamai, we've stand up an edge worker module. That's the script layer at the edge that you can intercept requests going to the CDN and do things with them. So one thing is we can both validate common access token and synthesize common access tokens there. There's docs up on the website about that, and there's a link to that as well. And there's also a public demo. I'm not actually sure if it's working right now. The guy in California has to wake up and then reboot the server. I was trying to get him to do it before now, but as soon as he does, it should be up and running. So check it out. You can create tokens, and then there's a media player under that. You can play it, see if it blocks you, see if it doesn't, but it's a working demonstration. And that, I think, is my last slide. So thank you very much.
Great. Thank you very much. There are some people in the queue, and I'll take this opportunity as Lucas is coming up to remind everybody who joined late to please make sure to join the Meet Echo session, even as a on-site participant, both for purposes of asking questions and for purposes of room sizing for future meetings. Thanks.
Hello.
Hey, Lucas.
Sorry for being late. I'm Lucas. Thanks for the presentation. Well, I only caught part of it, and it's interesting. I don't really know much about this area, but it's insightful. But the one thing that caught my eye was the geohash stuff. I don't know if you're following some of the discussion that's happening on the HTTP mailing list about GeoIP hints in headers being sent from clients, and there's various levels of discussion about privacy and all sorts of related things. So I was curious if that was using geohash or something else because of the complications you were talking about. They're using something called geofeeds, which is RFC, and I don't know anything about those technologies. So I just wondered if that was something you folks had considered and it wasn't right, or
No, it was not considered, to be clear. It may still be right and may be better. So it's maybe something we should look at.
I've got.
I mean,
no
it's
insight
published
here.
at
I
this
just
point.
wanted to,
Yeah.
to share. I'll share a link into the chat after.
Yeah,
with
that would be
the
great.
RFC number and
We
stuff.
can document it.
Cool. Thank you.
Thanks. Luke.
Hi there, Glendine. One comment on that is some of that work is a little bit different, I think, because here the stuff's encrypted and only the CDN side and the client side actually have access to it. So there's less of a privacy concern in this scenario than in the more general scenario he's maybe talking about with the other working group. I did want to make one point out, and by the way, thank you. This is maybe one of the best presentations I've seen on CAT, so thank you, well done. We need to get the word out. A lot of your use cases revolved around blocking or content enablement, but there's a range of use cases above and beyond that, which are selective content, delivery, selective content choices, and other richer content scenarios that become enabled if you start using the CAT and your logic there. And so I didn't want people to go away thinking it's just a yes or no, blocking technique is actually a richer thing that gives us new capabilities we didn't really have before. So this is actually really cool stuff for the future.
That's a good point. Thank you.
So Kyle Rose speaking as participant. Can you go back to the slide about the pirate graph? I have a clarification question.
Yes.
So, I mean, if do you mean rejected or revoked? Right. Okay. Okay. Yeah, that makes a lot more sense because otherwise every individual is still only going to see it rejected
Right.
0.005%.
You do need to remember it once you.
Right. So there's
yeah.
some shared state that's
Yeah.
required in order for this to actually be an effective anti-piracy measure.
But
Okay.
luckily, most requests are not pirates. So, like, if most requests you had to remember, now you have a memory problem on your Edge server.
Right. And presumably there's sufficient buffering that even if a legitimate user has theirs kicked out, they'll
go back, they'll
be smooth,
revalidate,
they won't
their
notice.
buffer will
Yeah.
decline by 500 milliseconds, and it's all good.
Okay.
And it'll be infrequent enough, and you can check as they revalidate, like, you can apply all your safety checks to see are they an authenticated user. But it's going to force, the goal is that the pirates are going to have to do this constantly.
Right. And
as
so
they
it
share the
simplifies the shared state that you need to maintain. You don't have a specific anti-piracy measure. This is just, yeah. Okay. Cool.
Yeah.
It's a side
It's-
effect.
Yeah.
Sorry, multitasking here. Okay, first thing I'd like to correct, the geohash is not one of the mandatory to encrypt claims. It is not. It is only mandatory to encrypt if the geohash is longer than 4 characters. So if you use a broad geohash that is roughly the size of a city, that is not mandatory to encrypt. You do have to encrypt it if you have reason to believe that that is likely to be personally identifiable, and that
It's not mandatory, but
you can encrypt it. And if you are interested in the question of how to encrypt claims, there are a number there are a number of ways of doing that. The simplest of which is that you can encrypt the entire token, because CWTs may be encrypted as well as signed, and that is supported here. But also in the composite claims draft that we have mentioned before, it also has a enveloped claim that allows you to replace the claim value with a cozy encrypt object and actually protect the value of that claim. So there are a couple of options available. And if you are being sufficiently specific about a user's location, then you do need to make sure that you protect that. But I did want to make sure that we were accurate on that particular point. The same thing is true of sufficiently accurate IP addresses, by the way. There are a number of claims that require conveyance inside an encrypted form of one sort or another. I wanted to point out and correct on the slides earlier, there was an example of the JSON. You actually used CDDL, or not CDDL, you used EDN for the CBOR instead of JSON for the example. In JSON, those tags would be strings, not numbers, and it would actually be bigger.
Okay.
But also the encoded example didn't include the signature on it, which also makes it bigger. So you may want to adjust both of those values to be more representative. It's still way smaller, but
Thanks. I'll get with you afterwards
yeah.
and make sure it's correct.
Wanted to make sure people knew that was going on. It's tends to be about a quarter the size of what it would be if it were JSON.
Thank you. Any other questions? All right. Thank you very much, Will.
Okay. Thank you.
Glenn, if you'd like to come up. Yep.
Still trying to figure out how to.
Eric Vink as an individual contributor. Question for Will. It took me time, sorry. What's the interest of you coming here to present your work at the IETF? I mean, for this, of course, right? We are kind of a forum, but you are presenting at MOC as well? Just curious, right? So,
the interest I was asked to present it by the chairs. So I think we think it's of general utility in delivering media, and hence I think it's relevant for this audience. In terms of MOC, we're looking at early at standardizing access control, and we have room for tokens, but we haven't used any or suggested any. So whether we do or don't, I'm not sure what we'll do in that regard, but at least the notion is here's a standardized token. We can use it for HTTP access, and we can use it for access over MOC transport as well.
and by the way, your presence here is pretty welcome, right? Useful.
And to that point, Eric, I think there's also, when they're doing some of the work, some question about what parts should they develop at the IETF or not develop at the IETF, because there's obviously some intersectional overlap.
Do you, is this network overlays or?
No, this is the SVTA. I submitted it.
Oh, yeah, no.
You approved
sorry,
it.
I had to scroll down. Got it.
Not scrolling.
Yeah. Go figure.
Hi there. This is the usual update we do for the SVTA because we have this cross-pollination. Next slide. So I'm Glenn Dean from NBC Universal Comcast. And I do stuff at the SVTA and I do stuff at IETF. And as a lot of people, I'm really pleased to see how many people in the room here are actually active in both groups. We got my co-chair over here, Gwendol, who actually co-chairs my networking and transport group over at SVTA. I point that out because there is so much overlap between what the two groups do. And this is one of the reasons why either Sanjay has done it in the past or I've done it, I'm doing it today. We come in, we give an update about what's going on at the SVTA and what is going on at IETF. And I go over there and do the same thing to that crew so that we can bring the two groups together because we have a lot of common interests. We have a lot of common questions, and having us in sync, not lockstep, but aware of each other helps us prevent the situation where one group goes off and does something completely independent of the other group, and then later on we have two standards or three or four that are in conflict. So in particular, I wanted to highlight a few things at the SVTA and then highlight things at IETF and where the joint is here, right? So we have open caching at SVTA, that's hierarchical CDN stuff, which is based upon CDNI here at the IETF. I co-chair a group on networking and transport that has been doing, for instance, a long evolving quick POC where we are looking at the use of quick as a HTTP3 as a replacement streaming choice for HTTP2 and asking the question, is it better, is it worse? Turns out, by the way, the answer we've come across so far is it's about the same. For just regular streaming as a replacement, it's about the same. You don't lose anything, you don't gain anything. Life goes on. Pick the one you like. But obviously we're doing quick over here at the IETF, and here at the IETF, media over quick. And that's something we've had a lot of interest in and have been tracking and providing feedback from the group. And also the media over quick group here at the IETF has grabbed a bunch of people that are SVTA networking and transport people that have come over here and started helping contribute to that. So I think the relationship's working really well. Security is going on. I mentioned the quick PLC, but obviously DNS is something that is very vital and core to delivering a video. So it's something we have a lot of interest in both groups and many more. So my takeaway here is if you're working in these areas at the IETF, you may want to also look at what practically from an operations standpoint for the video use cases going on in SVTA. And by the way, when I'm over there, I say, SVTA guys, you should be more involved at the IETF. And they hear me all the time saying that particular thing. And MOPS is, come to MOPS if you're scared. I will give you a gentle introduction to the IETF. Next slide, please. This is a great example of the various things that, in fact, this is an extract from one of our documents. On the types of RFC dependencies the IETF specs actually draw upon and feed back into. So, it touches a lot of stuff, a lot of content here, especially the CDNI, but also if you look at the JSON and we had the JOT stuff mentioned the last talk, that's on here too. And by the way, this was prepared with AI. There's a tool we're experimenting with, which data mines specifications and allows you to ask questions to the AI about, I literally asked it, what IETF RFCs are there dependencies upon? And it produced this, which is pretty awesome. It saves having to cut and paste through documents. Really, I like it. It might be something we want to look at the IETF. Next slide, please. One of the big updates, -IF has joined the SVTA. We are now one happy big family. Well, we're one family. We're still working on happy, but we're pretty happy. But this is huge. -IF does a lot of great work. And it was a conversation we had, took place for about a year of, should we get together? Should we, you want to go on a date? Let's see if it'll work out. We're now one group. So if you are a member of -IF, start coming to SVTA meetings. That's where we're going to meet, and vice versa. In particular, I also want to point out, Will, welcome to the SVTA. Akamai has joined. So has Qualcomm and Netflix. So we're getting bigger. So if you wonder if you are a member, you might already be a member. You never know. I think we're getting a lot of overlap. Next slide, please. So for things we are doing that are relevant here and of interest, in fact, we talked about some of this stuff, but CDNI has a lot of work going on in 2024. We have some security checklist stuff going on. So obviously security is a big thing. So encryption, locking things down, looking at logs, log analysis is a big topic we worry about over there. And there's a lot of intersections to the stuff we do here. We talked about CMCD, various things. We talked about CDN leeching a little bit here. Common access token wave, that was jointly done actually partially with SVTA. In 2025, things we on the pipeline, streaming best practices, open casting, network overlay impacts. That document that Sanjay showed here earlier started its work over there because we started saying, we got this problem. Oh gosh, where do we take it to go talk about that problem? We could take it to the IETF. Standardization of error player codes. If you're interested in codes and that kind of stuff, that's probably going to be something that is going to have a lot of joint work here. We'll probably bring some stuff over. And then architectures for multi-CDN switching is something we're starting to talk about as one of the work items for next year. So I think there's going to be an ongoing relationship between the IETF for years to come. Next slide, please. So if you want to come, we already know how to get to IETF meetings. I'm going to make it really easy for you next year. We have a member meeting in Tucson. It's not joint with the IETF, but the next 2 meetings after that are going to be in the same city the week of joining the IETF. So when we go to Madrid for IETF, we're also going to be in Madrid for the SVTA, along with the SVTA Open Industry Conference. So if you're not a member, you can still come to the Open Industry Conference called Segments to talk about video. And it's a very operations focused conference. So if you are interested in operations topics, that's where we're going to be discussing it in Madrid. Likewise, at the IETF meeting in Montreal in November, the SVTA is also going to jointly meet there, along with having on Halloween a North American version of the Segments Conference. So hopefully we're going to build an even better relationship between the 2 groups going forward and only get better. Next slide, I think it's the end.
No, that's it.
So that's it. Any questions? Come see me, come see Gwendol, come see Sanjay, and now come see Will, because he's an SVTA guy too. Yes, Sanjay.
Just a quick something to point out on your previous slide. SVTA is also a member of Metaverse Standard Forums. And so we are actually doing a joint, so they have a town hall session coming up later this month. And SVTA Immersive Video Study Group is presenting at the Metaverse Standard Forum.
Do you have any involvement in the SVTA Immersive Video group, Sanjay?
Yes.
Are you a co-chair of that group, Sanjay?
I do co-chair that group, yes. Yes.
Are you asking leading questions, Glenn?
Anyways, look, we've done a lot of great stuff the last few years together with the IETF. I'm really excited about the future. So everything's going just fantastically well. So thank you for coming to MOPS and participating. And I'm very happy. So all good.
Any other questions? Thank you, Glenn. Any other questions? Are we all happy about maybe having 40 minutes back? All right. Well, thank you all for coming. Again, please make sure that you've logged in via MeetEcho. And thanks again to Chris Lemons for taking our notes today. Thank you all. I'm, the animated GIF would be.
It's actually an MP4 video that's looping, so I need to convert it to
Cool. Thank you.
All right.
Cool. No,
Just leave the room. There, I'm done. I'm done for the week. Like all the things I had to do here are done. Now I just have to stay here till Saturday.
I mean, you can always reschedule if you want.
More expensive than it might finish here.
I mean, it depends. Like usually, I very rarely want to be paid more when I reschedule other than.
Let's talk about
You talked to Tail about his tail and blow.
Oh, what?
Because he booked the flight, got a cheap rate on